here we have the graph of y equals 0, or 0 times x as you've written here, but 0. No matter what x is, y is 0. It's difficult to see, but the graph is on top of the x-axis. It's a horizontal line with slope 0. But if I increase this number in front of the x, let's change it to, increase. Let's see if I can get it to be 0.5. And here I have y equals 0.5x, or half x. And here we have a line passing through the origin with slope a half. As I go along 1, I go up a half. If I go up 1, I go along 2. If I go up 2, I go along 4. The slope is a half. If I make that up to 1, and we can see a slope of 1. This is y equals x, or y equals 1x. As I go along 1, I go up 1. So our rise over run gives us 1. And I can increase this slope and make it, let's say, 2. And here I have a slope of 2, a rise of 2 for a run of 1, passing through the origin. And this sort of graph is like the price of apples. This would be apples being £2 per kilogram if I got kilograms going this way and price going this way. Okay, the negative numbers might make no sense in this example, but this will tell me if I buy 2 kilos of apples, it will cost me £4. 3 kilos, it will cost me £6. 0.2 of a kilo, and it will cost me 0.4 of a pound, 40 pence, etc. And we can make the price increase by changing the slope. So here we have £3 per kilo. If I can get it to sit right. Here we have £3 per kilo, a slope of 3, and so on. And we talk about the price being a bit steep. So we can change this to a slope of 10 and down. There's a slope of £2.64 per kilo, and there we go. As we go through the negative numbers, we can get steeper and steeper down, and then we can return. So our equation here is y equals mx plus, well, y equals mx for the slope. M is the slope. If I can make that back to 1, that would be nice. So here we have the graph of y equals 1x, slope of 1. So this gives me lots of straight lines, but they all pass through the origin. I could add a number to this. I could say, well, what is y equals 1x plus 1? Well, that's a graph still with a slope of 1, but passes through the point 0, 1. And we can increase this and just move the graph up and down by adding a number on the end. We can make it appear at the origin or at negative values over here, wherever we wish. So here we have an equation of y equals x plus 2. Get that right. This sort of graph might in the real world be for something like catching a taxi. As soon as you get in a taxi, you have to pay so many pounds. As soon as they turn the meter on, that's for getting the taxi to arrive to you and pick you up. And then it costs so much per kilometre after that. So in general, the formula for these straight lines is y equals mx plus c, and this c, as I change it, you can see, is where it crosses the y-axis. So I've got all these straight lines. Their equations are y equals mx plus c, where m is the slope. For some reason we use m, which is from some French word that means slope or gradient, plus c plus the y-intercept. So we add the y-intercept to move the graph up and down. And that covers very nearly every straight line graph, but not the ones with an undefined slope. And if I wanted to do that, I would have to say x is equal to some number. And here I get a graph of a vertical line. Here the slope is undefined, and here I've got x equals 1. Y can be whatever it likes, x will not change, it is always 1, but I can make x to be 0, so that will be your y-axis. I can make x negative or positive and move the line along here. But those are unusual, and we are more interested in the ones that have the formula y equals mx plus c. C is some constant that moves us up and down, that's the y-intercept, and m is the slope. So the equation of a straight line is called a linear equation, to do with a line, and it is y equals mx plus c. M is the slope or the gradient. C is the y-intercept, where the graph crosses the y-axis, and if c is 0, the graph passes through the origin, like the price of apples. If the slope is 0, we get a horizontal line, y equals c, and a positive gradient slopes up and a negative gradient slopes down. It is also possible to deal with an undefined slope. X equals k gives a vertical line, but that's not so important at all. So this shows very clearly the relationship between rise and run, slope and y-intercept. Here I have a rise of 4, a run of 4, so my slope is 1, my y-intercept is 0, so my equation is y equals x. If I were to make the run shorter, here we have a run of 2 and a rise of 4, so my slope is 2. I have y equals 2x when x is 1, y is 2, when x is 2, y is 4, and so on. I can move the graph up and down, so this will be y equals 2x plus 1. I could reduce the rise back down to 2, and here I have y equals x plus 1, a slope of 1 because the rise and run are equal, and I can make my rise negative or even 0. There we are. That's the graph y equals 1 and negative. There we have a minus 1 and minus 2, and we can move the graph up and down as we see fit. So here my run is 2, my rise is minus 4, so the slope is minus 2. The equation will be y equals minus 2x plus 4, because that's the y-intercept. So if I'm given the graph of a line and asked to find its equation, I need to find some points where the line crosses grid lines and find my rise and my run. So here my rise is the change in y, and here I'm passing through the points 0, 1 and 5, 5. So my change in y is 5 minus 1 is 4. And my change in x is 5 minus 0 is 5. So my slope will be the change in y over the change in x, which will be 4 over 5, 4/5. My y-intercept here is 1, so my equation will be y equals 4/5 x plus 1. Another question I might be asked is to find the equation of a line given 2 points that the line passes through. Now 2 points is sufficient to describe a line, and what I can do is find the change in x and the change in y, the rise and the run, and here I get, if I can get this just perfect, so my change in y, my rise, will be 9 minus 3, and my change in x will be 10 minus 5, so that's 12 over 15 or 4/5, and I'm going to get the same answer. But we can do this without drawing a graph. So if you're asked to find the equation of a line passing through 2 points, you don't need to draw the graph. First of all, we need to find the slope, which is my rise over my run, and my rise is my change in y, and my y has gone from 9 to minus 3. So to find the change, it's 9 minus 3, and my change in x, well, that's changed from 10 to minus 5, so that's 10 minus 5. 9 minus 3 is 9 plus 3 is 12. 10 minus 5 is 10 plus 5 is 15. And this will cancel down to give me 4/5. So I know my equation is y is 4/5 x plus some constant c. And I don't know what that is. I know it's the y-intercept, but I don't know the y-intercept. So what I can do is use either of these points here to tell me, because I know that this equation must be true at these points, and I'm going to take the one with the positive values. So I know at this point here x is 10 and y is 9. So this equation y equals 4/5 x plus c must be true when y is 9 and x is 10. So I can put 9 for y. I've got 4/5 and my x and times 10 plus c. But now I can do a little cancelling, because here I have a 10 on the top and a 5 on the bottom. I can divide top and bottom by 5 to get just a 2 here. And now my equation becomes 9 equals 2 times 4 is 8 plus c. So c must be 1. And I can subtract 8 from both sides to get c equals 1. And my equation is y equals 4/5 x plus 1. And I can check by substituting. If I substitute the points, x is 10 in here, I'll get 4/5 of 10, which will be 8 plus 1, and that would be y is 9, and that matches with this point over here. I can substitute this point here, and here I will get y, which is minus 3, is equal to 4/5 of minus 5 plus 1. 4/5 of minus 5 will be minus 4 plus 1, which will give me minus 3, and minus 3 is minus 3, and I can be happy that I have the right equation. So here, if we're asked to find the equation of a line with a given slope passing through a point, this is actually easier because we don't need to find the slope. The question has told it to us. So we know the equation is going to be y is the slope, which is given in the question, minus 0.5x plus c. We also know that this point is on that line, so that the equation must be true for this point, and this point is when x is 2 and y is 1. So if we substitute those, we get y is 1 is minus 0.5 times a 2 plus c. Minus a half of 2 is minus 1, so 1 is minus 1 plus c. Add 1 to both sides, 2 equals c, or c equals 2, and my equation then must be y is minus 0.5x plus 2. Here we can see the equation of parallel lines. My blue line here is y is 2x minus 1. We have a rise of 2 and a run of 1, so a slope of 2, and the y-intercept is minus 1. And here I have a line parallel to that, passing through the point 4, 3. It has a rise of 2 and a run of 1, and its y-intercept will be down here at minus 5. And its formula will be y equals 2x minus 5, because it has the same slope. Parallel lines have the same slope. Now I can move A to B anywhere I wish, and it will still have the slope of 2. If I change my original line to have a different slope, then here we can see slope of 1, and we can see y equals x minus 1 and y equals x plus 2, and I can pick any other point and ask for a line parallel to my original line, but it must have the same slope, even if I make my slope 0 or negative. So parallel lines must have the same slope, and if I were asked, I should be able to find the equation of a line parallel to a given one passing through a particular point. So if we're asked to find the equation of a line parallel to y equals 3x minus 2 passing through a given point minus 5, 3, then we know that the slope of the line must be the same as the slope of the line that we're given. So the equation must be y equals 3x plus something. All lines parallel to y equals 3x minus 2 will have the form y equals 3x plus c. And now again, we need to substitute our points. X is minus 5, y is 3, so we have 3 is 3 times minus 5 plus c. 3 is equal to minus 15 plus c. Add 15 to both sides, and I'll get 18 equals c. So my equation must be y equals 3x plus 18. So if we can find the equation of a line parallel to a given line, can we find the equation of a line that is at right angles to it, at perpendicular to it? And the answer is yes, we can. Now if it's going to be at right angles, This original line, the blue line here, has a rise of 2 and a run of 1. The line we want is going to slope down, so it's going to have a negative rise, but it's not going to be a rise of -2 and a run of 1, because that would give much more than 90 degrees. In fact, what we really need is for the rise and the run to be swapped round. We need a run of 2 and a rise of -1 to give ourselves a line at right angles. So here we can see such a line. These cross at right angles, and this is a line perpendicular at right angles to the original y equals 2x minus 1, but it has a rise of -1 and a run of 2. Maybe we can see that more clearly if I move this over here. And therefore the slope is -1/2. If I change the slope, we can see that here we have a slope of 3, and here we have a slope of -1/3. Here I can change my slope down to 1, and my slope will be -1 of the perpendicular line. If I were to make it a horizontal line, then we need a vertical line, and then we can move across to a negative slope here. Here we have a negative slope of -1, a run of 1 and a rise of -1. So the perpendicular line will have a run of 1 and a rise of 1. Its equation will be y equals 1x plus something. This will be -1x. But we can choose any point we like and make ourselves a perpendicular line. And we need to be able to find that equation. So the first thing is to recognize that the slope will be the opposite sign, so we'll multiply on the negative of the original, and it will be the reciprocal. If my slope is -2, then the reciprocal will be +1/2. And it's always the opposite or negative reciprocal for the slope of a perpendicular line. So, to find the equation of a line perpendicular to a given line, then we need to find the slope of the line perpendicular to this. And here the slope is 2, and the negative or opposite reciprocal will be -1/2. We think of 2 as being 2 over 1. We make it minus, that's -2 over 1. We take the reciprocal, that's -1/2. So all lines perpendicular to y equals 2x plus 1 or plus anything will have the form y is -1/2x plus something. And now we can apply our trick of substituting our given point. Here x is 2 and y is 2. The second 2 here we put here, and this first 2 we put in for our x. So that's -1/2 of 2 plus c. So 2 is -1/2 of 2 is -1 plus c. We add 1 to both sides, we get 3 equals c, and our equation must be y is -1/2 of x plus 3.